Hello, everyone. Welcome to today's webinar. My name is Alagu, and I take care of Europe sales. Along with me, I have Ken and Pratik. I will let them introduce themselves.
Hey, folks. I'm Pratik. I am the technical lead on Mingle, which is an agile project management tool that ThoughtWorks builds.
Hi, and I'm Ken. I'm a technology advocate. I teach people about continuous delivery and DevOps.
Hi. Before we go ahead with the webinar, I'll just quickly take you through a little bit about ThoughtWorks and who we are. And from there, we'll move on to the webinar. So ThoughtWorks is a global technology consultancy. We work with enterprise clients to solve their most complex technical challenges. And we were founded in Chicago in the year 1993. And in the early 2000s, Martin Fowler joined ThoughtWorks as a chief scientist. And in the year 2002, Martin took continuous integration mainstream. And we also, ThoughtWorks took the lead in creating the first open source continuous integration server called Cruise Control. From then on, 2006, ThoughtWorks formed a product division called ThoughtWorks Studios, and we started a new product called Cruise, which was the first continuous delivery server, which was then rebranded to GoCD. The product manager on GoCD then was Jez Humble, who also co-authored the book Continuous Delivery. In the year 2014, we open sourced GoCD, and right now we have a rich community of plugins and contributors to the product. Over to you, Ken and Pratik.
Okay, so I'll go through today's agenda a little bit. So first off, we're going to cover at high level some continuous delivery basics and some key practices, just as we're laying some groundwork. Then we'll introduce what we mean when we're talking about modern infrastructure, specifically Docker and Kubernetes today. We'll talk about how those aren't the only options, but they're our focus for today. We'll cover what we call the Docker-based build workflow, so using GoCD to actually build and deploy some of these things. Give an overview of GoCD, the product, and then a live demo of both deploying GoCD onto Kubernetes and using GoCD to deploy things to Kubernetes. At the end, we'll open up some Q&A. So everybody is muted. You'll notice that there's a Q&A blocks in your control. If you type your questions in there, some of them we'll try to answer real time via text as we can. Others we'll answer at the end live. If we're not able to get to your question, then we'll definitely follow up via email because we probably won't be able to get to all of them, just as a fair warning. So with that, I'm going to turn off video and do real content here. Okay, so first, just an overview of what we mean when we say continuous delivery. And I do this to make sure that we're all on the same page for everything we go forward. So this is the definition of continuous delivery by Jez Humble, who, as Alagu mentioned, co-authored a book by the same title, a book called Continuous Delivery, and also was the initial product manager for GoCD. Notice here that it talks about all changes to an application going through a pipeline. So it's not just new features. That's really common. Think about, I'm going to have my continuous delivery pipeline test all my new features. But it's also all the configuration changes, any experiments, et cetera. Everything should go through your pipeline when you're doing continuous delivery. So what do we mean when we say pipeline? Again, there's some different things out there, so I want to make sure we're all on the same basis. So to us, the purpose of a continuous delivery pipeline is to kill a release candidate. So what do I mean by that? In continuous delivery, every time I make a change, then that is considered a release candidate, and it's the continuous delivery pipeline's job to prove that it's not good enough. So you really can't prove something's good. I can set up a pipeline and not have any tests, and everything passes, and we can say, okay, it's good. That's really not a thing. You really have, but you can definitely prove that it's wrong or bad. So the way we set these up is somebody commits a change, and we run some fast running tests. I have them labeled here for this demo as build and unit tests, but the idea is to give the fastest possible feedback to the team. If it breaks, we stop work and fix it. So leaving a build red, those kinds of things is definitely an anti-pattern. It's something you should not do. I personally think flaky tests are worse than no tests. You really want to make sure that you can fix this right away. Now, that said, breaking the build is not a bad thing. I mean, it's not like, oh, you broke the build, here's your dunce cap, et cetera. We want to be testing boundaries. We want to do things. The job of a CD server is to catch this, so we're going to be fine. The team fixes it, and they go a little further, and now there's longer running tests. These are labeled automated acceptance, but again, they could be anything. Could be compliance, performance, et cetera. Now, at this stage, I like to differentiate two terms that are often interchanged and should not be. So continuous delivery is the practice of always having our software in a state where it could be given to customers. So we can make a decision, yes, we want to release. So GoCD itself is on-premises open source software. We don't do a quote-unquote production release many times a day, or people would have to upgrade many times a day. So it's continuous delivery. We choose when to release that version. Continuous deployment, on the other hand, is fully automated. So if all the tests pass, we end up in production. So like we have another product that's SaaS, that one deploys quite a bit more often. So you can do either one with GoCD, but that's the difference. So when we talk about continuous delivery, it means someone's actually pushing something. And from there, we go to deploy. Okay, so a couple other key concepts that are applicable to the subject of this webinar. First off is this concept of artifact management. And so we strongly believe that you should build a thing only once in your CD pipeline. So in this particular case, let's say that we're doing a jar file, so something relatively small. We commit some code, the CD server, GoCD, picks it up, does a build, stores that jar file in an artifact repository, and then later stages of our pipeline fetch that artifact and do what they need to do. So run particular kinds of tests, install it onto a staging environment if you have one, install it into production, et cetera. But the artifact itself is stored and passed along. We never rebuild the artifact. By the same token, we want to make sure that we do our environment changes the same way. So I commit changes. Maybe it's to a change management tool or what have you. And again, the pipeline executes that and we move things along. So from a GoCD perspective, this is what GoCD was architected to do almost a decade ago now, actually more than a decade ago now. And it works very, very well using, passing the artifact back and forth in a traditional build. So I'm building a jar, I'm building an MSI, I'm building a DLL, et cetera. It's a relatively small thing that I can store. That changes a little bit when we're talking about doing Docker and Kubernetes and so forth, and that kind of thing where it's a larger artifact, hence the changes we're making that we'll get into a little bit later in the webinar. Okay, so I'm going to give a high-level introduction to GoCD and what it is and where it came from. As we mentioned, in just a couple of minutes here, Pratik will be doing a live demo, so you'll get a lot more then. But first off, we've talked about it a little bit, but from a history perspective, three thought workers off of a project in London presented a white paper at an Agile conference in 2006 called the Deployment Production Line. And it's where we really started thinking about doing these things more like a production line. Introducing not only lean concepts for project management, but also taking those artifacts and moving them through our production line, stopping the line when something fails, and et cetera. 4 years after that, in 2010, the Continuous Delivery book was published. Obviously, I have some bias, but I do highly recommend the book. It's about practices, not specific technologies, so it really does stand the test of time. And it's been very, very popular. In between those two times is when First Name Cruise, and as Al mentioned, then rebranded to GoCD when that was released. Again, the original project manager was one of those authors, Jess Humble. So from an overview perspective, GoCD is now free and open source. So it was originally a commercial product we converted to open source about 4 years ago. So you can download it and try it and so forth, and there'll be resources at the end for that. And again, it was built specifically for continuous delivery. So, after Jez and Chris and Dan wrote the white paper and before the book came out, they were looking at continuous integration servers to solve this need, both Cruise Control that we created and, Hudson and Anthill Pro and all the things that were out there. And we just really feel like continuous delivery and continuous integration are fundamentally different things. the ability to manage a pipeline as a full thing, et cetera. And so this was built specifically for continuous delivery, which means things like that artifact management are built in. So I don't have to know which version it is and pass along, metadata to get the right jar, et cetera. It's all built in. It also gives us the ability to deploy any version at any time. So because the pipeline is one large related thing, if I have like that self-service QA environment, someone can go in and say, I want to deploy this version, or et cetera. There's a way they can choose that. The strong relationships also allow me to easily compare builds. So I can see between these two deploys to production, show me everything that changed back to every test case, every git commit, et cetera. So that's all provided because of the out-of-the-box support for complex pipelines. And so we have the ability to have fairly complex pipelines. Of course, they don't have to be. You can have a simple microservice pipeline. But if you do have a complex organization or organization of your code and so forth, GoCD supports that internally. So I can do multiple repositories, multiple builds, multiple stuff and so forth, and have integration pipelines and do things in parallel, and I can ensure everything is going to keep going. So GoCD itself. So GoCD, as I mentioned, is open source, free and open source software. It's on premises. It's not offered as a SaaS. And so traditionally and for years, we've had deployment installers for most major operating systems. In the last couple of years, we've added official AMIs if you want to run GoCD on Amazon, official Docker support, and recently, the subject of this webinar, official Kubernetes and Helm support. And so what happens is you install the server that does all the orchestration, all the scheduling, provides the GUI, et cetera. And then there are agents that actually execute the tasks. So these are what run Ant or what run Docker build or what run, et cetera. And so an important thing to note here, and I think a thing that's different than some other products, is that we're not considering like GoCD on Kubernetes as a new product. This is not a new thing. It's a new deployment target for an existing thing. And so that's why we did this. Now, there was some technology that we needed to do that you're going to see with Pratik here in a few minutes. But the point is that this is not like a new product that supports continuous delivery on Kubernetes. We're adding Kubernetes to our supported list of environments. The way we've chosen to do that, and again, you'll see this live, is we've created an official Helm chart for Go. So Helm is a tool that lets you package apps for deployment on Kubernetes. So if you're not familiar with Kubernetes, you can think of this like Yum or apt for Linux or Brew for Mac or Chocolatey for Windows. It's just a package manager. The other side of it, I mentioned the server, but there's also the agents, is we've added functionality to auto-scale the build agents on Kubernetes. And so, again, this is support we've had in other platforms for a little while that we call Elastic Agents with Docker, Docker Swarm, OpenStack, and some others. But what this means is that I don't have to have agents running at all. So in my job, I can define and I can say I need Docker and Maven, and it'll spin up Kubernetes pods, run up the agents, and do the work, and then store the artifacts and hand them out. So we needed to create this, and so that's also available now. Okay, so last section before I hand it over for the actual demo, we want to talk about what we mean when we say modern infrastructure, because it's a fairly overloaded term. For the purpose of this webinar, we're really talking about Docker and Kubernetes. Certainly Docker is not the only container system out there, but it's also the most popular. And saying Kubernetes isn't the only orchestration tool out there, but it is, again, in our experience, seems to be the most popular, and it's the topic of this webinar. So in case people aren't aware, because I know there's probably all levels of knowledge watching right now. So what Docker does for you is that you have your operating system and you run a Docker engine, and there's alternate ways to do this, but this is the basic high level. And then the applications themselves are packaged into these containers. And so everything about that application, its libraries, configuration, and what have you, is in a self-contained thing that can be run independently on multiple different hosts. Now, a lot of folks that are relatively new to Docker will treat it much like a virtual machine, and they really will put everything about that app in one container, so including the database and everything else, and they end up with these massive Docker containers. That's really not what you're supposed to do. What you're supposed to do is have, like, this is that application, this is the database, this is, maybe it's a messaging service or Kafka or whatever it is. But they're different containers that make up an entire application or product. So that brings in some difficulty. How do you manage all these different things together? And so again, there's tools for that. There's Docker Swarm and Docker Compose and ways to say that my actual product is these 6 Docker containers, etc. But again, it can get fairly complex. Enter the orchestration systems. So this is where Kubernetes comes into the picture. It's an open source orchestration tool for managing these. And so I can do things like Helm and describe a product, and it does all of the correct containers and all of the storage that it might need, etc. Additionally, Kubernetes has a really advanced API. I think that's one of the things that really led to its adoption the most. I heard somebody the other day refer to it as the new API for the internet, which is probably going a little too far. But the idea is that you can run Kubernetes on several different places, on Amazon or Microsoft or Google, etc. And the way you use it is fairly standardized, so it allows you to move things around. So what that allows us to do when we do Docker with Kubernetes is we're still storing the artifact, and Pratik's going to show you this, but we're not actually passing the whole thing around. We're using functionality like Docker Hub and so forth to promote it, and hence the things that we added to GoCD to do this. So that enables that Docker-based build workflow. And on purpose, we reused exactly the same slide. And so the message here is that we really don't think of this as a totally different thing. That's why, again, there's not a special product for doing continuous delivery on Kubernetes. From a process perspective, we manage this the same way. We commit source code, we do a build, it stores a thing, the later stages use that thing. Now, we're not passing around the whole thing, we're stored in a Docker repo, et cetera, but from a process perspective and from a learning perspective, it's still continuous delivery. And that's kind of the key takeaway of one of the reasons why we did it this way. So with that, I will turn it over to Pratik for the actual demo.
Thanks for that introduction, Ken. So let's just go through what we'll cover as a part of the demo right now. So what we will talk about is first the prerequisites. This is what you will need to get GoCD installed onto your Kubernetes cluster. So we'll cover what prerequisites you need first. And then we'll look at the actual installation of GoCD on Kubernetes. This will involve using the Helm chart that Ken mentioned. Post that, we will look at build pipelines and just an overview of what build pipelines in GoCD look like. That's for people who are not used to GoCD before, who've not seen GoCD before. Then what we'll jump into some live triggering of the pipeline. So we'll push a commit and see how that goes through the entire continuous delivery system that we have set up. So we'll see how that goes through each pipeline on GoCD. In the end, we will look at what plugins and what configuration of these plugins on GoCD enable this Docker-based workflow, so we can actually install GoCD on Kubernetes as well as use it to deploy our applications to Kubernetes. So let me just quickly start with the prerequisites. So I've for the first part of prerequisites as well as installing it, I have recorded that part and I'll be playing a video and I'll talk through it. This is just to avoid any network latencies that we could have while talking to GKE, that is the Google's Kubernetes engine. What you need to install GoCD is a Kubernetes cluster, and along with that, you will need kubectl or kubectl, which is the command line utility to talk to your Kubernetes cluster. So you need kubectl installed locally. and you need kubectl to be pointing to your Kubernetes cluster. You can run kubectl config and current context. You can run this command to see which cluster this your command line interface for Kubernetes is talking to. So in this case, I have kubectl talking to a cluster that I've set up on GKE. So this cluster could be anywhere. It could be on your local machine using Minikube. It could be on Amazon. It could be on Azure service. So it could be any. It could be on any cloud provider. But what you will need is your current local kubectl pointing to that cluster. So that's one thing you need. And the next thing that empowers this is Helm. So you'll need the Helm's command line interface installed on your system. So what Ken mentioned was Helm lets you package applications for Kubernetes. So what you do is you run Helm init. And Helm comes with two parts. One would be the command line interface and another server-side component called Tiller. So once you run Helm init, it sets up Tiller on your cluster. What Tiller essentially does is Tiller is a pod that runs at the cubes under the kube system namespace on Kubernetes, and it has privileges to provision pods and make releases for you. So if you look at the pods under the kube system namespace, once you do a Helm init, you will see this Tiller deploy pod under the kube system namespace. So this is what will be this. So your local command line interface actually talks to the Tiller component and helps you do deployments onto your Kubernetes cluster. So this is what you will need. These are what are the prerequisites to install GoCD on top of your Kubernetes cluster. Let's just look at what the installation is like. So to enable installation of GoCD on top of Kubernetes, what we have done is we have packaged it as a Helm chart. So packages in Helm are known as charts. So you can search the curated list of packages available on Helm using Helm search. So you say Helm search GoCD, and you will see that we have a stable GoCD version 1.1, the chart version available. So to install this particular version, you can use Helm and say Helm install, and then you will pass a few parameters. The first one will be the version of the name of the chart that you want installed. And then you give a name to the particular release that you're making and the namespace on Kubernetes where you would like to install GoCD. So in this case, I have given the name saying GoCD live demo, and the namespace would be GoCD live demo. And when we run that, Helm should make a release for us, which will essentially deploy GoCD onto a cluster. So we see a few things happen here. The first thing is there is some metadata that has been printed here. And so Helm gives you information about the components, the resources that it has actually deployed onto your Kubernetes cluster. So you notice the service, the config maps, and the cluster role, and it'll do a GoCD server deployment, as well as set up ingress so you can actually talk to your particular GoCD instance. Along with that, you'll find post-installation notes, some of which are basic information about what has been deployed and how do you access your GoCD publicly. So you can search for the public, you can run this particular command and you can see what is the IP address that has been allocated. So you can actually connect to your GoCD server. So like I mentioned, Helm actually deploys your applications. It creates release. It manages deployments using releases. So you can list all your releases using the Helm list command. And if you notice, we have a few releases here. GoCD live demo is the release that we were just doing in this video. And GoCD stable is a pre-baked Go server that I have on the same cluster. So because GoCD live demo can take some time to come up, we look at the pre-baked server, and which has a few pipelines set up, so we can go over them. So we can run health status GoCD stable, which will give us the same metadata that you saw for the new installation as well. What we will do is we'll go down to the deployment notes, and we will use the command to find what the public IP of this particular instance is. So in this case, I have also set up my hostname server.gocd demo.org to point to this particular public IP address. So this is so that it's easier to access your GoCD instance. So that has been done through a DNS entry and on the Google Cloud account. So this is what the pre-baked installation looks like. So these 4 pipelines have been created so that we can actually understand, go over the overview of GoCD. But just the plain installation will give you everything here except for these pipelines that are pre-set up. So let's quickly jump into looking at now that we have GoCD installed and we've seen what you need and how to install GoCD onto a Kubernetes cluster. We'll do a basic overview of GoCD itself. So let me quickly go to the GoCD instance. All right. So so the white boxes that you see here are pipelines, and each pipeline can have multiple stages. So we have 2 stages for the build and test pipeline here, which is the default stage and a vulnerability test stages. And these stages run in sequence. So if any stage fails, the upcoming stages don't run, and the entire pipeline is marked as failed. Every stage in itself has parallel jobs that run. So if you noticed performance test, component jobs, and the default job, these run in parallel for each stage. Again, if a job fails, that stage will be marked as failed. So if you click on the name of the particular pipeline, you can see a history of old runs that have happened, and you can also see what has triggered these pipelines to run. So you can see the changes in the Git repository that have actually triggered each of these runs. So you can also go ahead and compare what are the changes between 2 different runs, and also you have the ability to go back and run an old stage. So you can use that to provision old builds or roll back to old deployments, and so on and so forth. You can also look at value stream map. So this is another view that you get in GoCD, which helps you visualize your end-to-end continuous delivery setup. So here, continuous delivery pipeline. So here you can see that we have a test pipeline, a build and test pipeline that fans out into multiple test pipelines, and then fans into deployment. So we'll talk more about fan out and fan in when we go over the entire pipeline. So this view actually and also gives you information on how long it took for each pipeline to run. So you can find out inefficiencies in your in your continuous deployment setup if there are any bottlenecks in certain stages or pipelines that you can identify them. So that's a brief overview of GoCD. What we'll do now is we'll look at this particular Docker build workflow that we have set up, and we will trigger a live commit onto this pipeline and see it go through each stage and go over how this workflow has been set up. So what we have first is, in this case, what we are deploying is the Kubernetes guestbook sample app. What we're doing is we're building the app, running certain tests against it, and then deploying into two environments, both onto the same Kubernetes cluster in this case. So you have the CI build and test pipeline, where we first build the Docker image for the application, and then we fan out. We spoke about fan out earlier, into 2 pipelines. So what fan out essentially lets you do is it enables you to trigger multiple pipelines from one particular change. So so these pipelines could be managed by separate teams. They could be running very different tests. In this case, we're running one set of functional tests and acceptance tests in parallel, and if you notice, that fans into a deployment to staging in stage. So unless both functional tests and acceptance tests are green, deployments to staging will not run. So you run the same build throughout the entire flow. So that's what fan out and fan in. It ensures that the same artifact has been tested across on multiple pipelines with the same changes that went through. So in the deploy to staging, we deploy the guestbook. We take the image and we deploy the guestbook app to Helm, using Helm to our Kubernetes cluster into the staging namespace. And in deploy to prod, it's essentially the same thing, but we deploy to a production namespace. So what I'll do now is I will trigger a commit into this repository, and then we'll go over how the process works. So let me just have a script to just push commit into the pipeline. So the moment I push a commit, we should see the build and test pipeline get triggered. So let's just, it should be maybe in a couple of seconds that we see this particular pipeline get triggered. And then we'll go over what happens in the build and test stage and how, so now we can see that this went into yellow. So let's go, and we'll see how the artifact actually flows across this continuous delivery pipeline and gets deployed into the Kubernetes cluster. So we run a few tests, but the default job here, this is the job that that will build the Docker image, and this job exports an artifact. So artifact is anything that is a result of the particular job that you have run. It can be reports, it can be logs that you want, it can be wars or any artifact that moves forward into your pipeline. So in this case, our artifact is actually going to be a Docker image, and we'll generate a metadata JSON file that will be used further into deployments to because that points because we'll have metadata about the Docker image that has to be deployed. So that is exported as an artifact, and that will actually be pushed to the Docker registry using the Docker artifact plugin on GoCD. So if you notice here, we use the Docker build command, and we're building the guestbook app, and this will actually build the Docker image. Another thing we can see is that it's running on a certain agent. So if you click on check agent status, what GoServer does is it essentially creates pods on your Kubernetes cluster, agent pods that run your jobs when required. So this pod was just, this is using the Elastic Agent plugin for Kubernetes. So this will provision a pod for you, and you get information about the pod name, the namespace, etc. You also get events around the pod directly streamed back into GoCD. So you don't have to actually look at your Kubernetes cluster or dashboard. You get all that information here. You get the logs here, as well as you can see the configuration in which this agent pod was provisioned. So you get all that information right here, and the live stream of logs from the running job. So it looks like, so you see that the job has passed, and what we do is we create this artifact JSON which has metadata about the particular Docker image that was built. And another thing that happens is I mentioned about the artifact repository plugin for Docker, and what that does is it takes your Docker image and the image that we just built, and it's pushing it to a Docker registry here. So we've configured the Docker the artifact plugin to registry plugin to point to our registry, and this image will be pushed to that particular registry. So let's quickly go up to looking at what happens further. So we fan out now into functional and acceptance stages. Now in functional tests, we have we use so first thing is we pull this pluggable artifact, which is nothing but the Docker image from registry. So this is again done as a part of the plugin artifact repository plugin. So I'm still going through. Let me just quickly look at an older run. So we pull the artifact and then we run functional tests against it using. So we have Docker and Docker enabled for these agents. So if you have your test set up as a Docker image, you can run your Docker commands inside it. So in this case, we're running Gauge tests using the Gauge test automation framework that ThoughtWorks builds. So we run these automation tests, and once it goes through, so you can just look back at the VSM. Sorry, let's go back. Yeah. So if you look at the let's look at the 1 second. Let me go back to the build VSM so we can see the entire flow. Yeah. So if you look at the VSM, so we run functional and acceptance tests in parallel. So once these two go through, the deployment stage triggers. And so what we're doing is, so in deployment, you can choose multiple options. A preferred way would be to package your application into a Helm chart and use that to deploy to your Kubernetes cluster. So here we use we've created a guestbook. So there's a guestbook Helm chart that we use, and we essentially fetch the metadata JSON file. The JSON file is used to fetch the Docker image, and we use Helm. You would use Helm here to deploy to your Kubernetes cluster. So in this case, we're deploying to a guestbook staging namespace on the Kubernetes cluster. And what we also do as after deployment is we wait for a successful release using Helm, and that status has been published as a custom tab here, so you can actually see what exactly got deployed onto the staging namespace. So we have ingress set up as well as a host name entry in our a DNS entry to directly use a host name to point to this. So what I will do is go to staging. So the guestbook staging app gets deployed onto this instance. So if we go back and look at the deploy to production, it basically does the same thing. So like Ken mentioned, it would be pretty much the same. The only thing that changes here is the namespace you deploy to. So in your case, you could ideally be deploying to a different cluster. In this case, we're deploying the same cluster on a different namespace. So we pull the artifact again, which is the Docker image, and we use the Helm chart to deploy this particular chart onto the Kubernetes cluster, and this waits for the successful status from Helm and publishes the release information here. So that's how you would model an end-to-end flow to deploy, to build your app as a Docker image and deploy it onto a Kubernetes using GoCD. What we'll do now is just go over the couple of plugins that empower this. So we spoke about a few plugins, and I'll just quickly go to the plugins tab to show you which there were. So the first plugin that we talked about was the Kubernetes Elastic Agent plugin. So this comes packaged with the GoCD Helm chart. So once you install it, this plugin gets set up automatically. And what it essentially does is it provisions agent pods on the fly whenever there's requirements to run builds, and this configuration is again done as a part of the installation. You don't have to do any of these. So it sets up the cluster URL as well as a security token with enough privileges for it to provision pods. So this is the Kubernetes Elastic Agent plugin, and along with that, we also have the Artifact plugin for Docker, which you can configure to publish to your Docker registry. It could be Docker Hub, or it could be on Google Cloud. So, or your own registry that you're running. So you can configure it. So this plugin should be live by the end of the month, I think. So Yeah, so these two plugins actually enable. We have some other plugins installed here. This is just for authorization and that you can use on your GoCD instance. So yeah, that's all I have from the demo here. I'll hand it over back to Ken, who will give you an overview of what we just went through.
Cool. Thanks, Pratik. So we got a couple questions here that we want to answer. So we'll go through some of those. Again, just a reminder, if you'd like to ask questions, there's a Q&A box in the Zoom controls. If you type the question in there, we'll try to get to all that we can. If we can't, we'll send you via email later. Actually, I'll go ahead and start the video here too, because it would be more personal that way. Okay. So there's a couple here that I'm going to combine. So first off, two people asked. One person asked, can we use GoCD with Azure AKS? And somebody else asked about OpenShift. So we've set up instructions, pretty detailed instructions for doing it on Google Cloud, but really it's just Kubernetes. And so there really shouldn't be a reason why it doesn't work on those, because the Helm chart certainly would. If you set up the cluster correctly and you Helm install, GoCD itself would definitely run there and be able to deploy to there. I don't think have detailed instructions for actually setting up their cloud services. I imagine we will soon, but we don't yet. So I'll mark those as done, but please go ahead and do follow-ups if you have them. Another question, somebody was asking about the authoring of pipelines themselves in GoCD. Is it file-based or UI-based? And they specifically said, is it possible to show an example? And so I've set up just exactly that, if I can exit here. Okay, so this is a GoCD instance. It's another demo instance. So the answer to the question of how do I author the pipelines is there's a lot of different ways. So GoCD itself is a Jetty application. It uses an internal configuration that's stored in XML that allows you to either edit that XML or there's a GUI up here. So I can go, into pipelines and go in and configure it in here if you want to. But even if I use the GUI, what it's actually doing is writing to the XML and committing it to an internal Git repository. There is a full-featured API for this. And so I don't have an example here, but somebody wrote an open source thing called Gomatic, which is Python. So you write your codes in Python and it uses the API to do it. So that's the internal configuration of GoCD. There's also fully supported external authoring and configuring of GoCD. And so these fully official support, both YAML and JSON. So like this is the Git repo. For that, I can go in and there's the example since it was specifically in the question. So again, either one. You can do internal configuration. It's often easier for like getting started because we do a lot of sanity checks and those kinds of things. But you don't have to. You can use the external if you prefer. Okay, so back to the questions here. Pratik wanted to answer one here.
Yeah, so someone asked if there's a way to specify a manual step, for example, deploy to staging. Yes, you can do that. So let me just quickly show you. So if you have a particular,
you're not sharing. Oh yeah, sorry.
Yeah. So if in this case, in the example that we saw, we had deploy to prod automatically run after staging deployment, but you could just go into the stage and the job settings, into the job settings and make it manual. So if you made it manual, then you would have to go ahead and push a button to deploy every time you wanted. So that is possible.
Cool. Okay, so mark that one done. That one. Somebody asked about a plugin to track in external tools. No, there's not. So I don't want to only answer yeses to the things. So you can do like a basic regular expression. So I can say give it a Jira ticket number, and we can rewrite a URL. So in the commit log, when you see that where he showed you the changes to Git, you can go in and see a link to that Jira ticket or what have you. Lots of people will add scripts that do API calls or what have you to update it. I haven't talked to Pratik about this, but I'm not personally a fan of that because the fact that we've committed code and even have a green build doesn't necessarily mean that ticket's really done, that the bug is fixed or what have you. In continuous integration, we're committing code every day, even if we're not quote unquote done with the work. So I don't really like to automatically update those systems. Somebody asked, is there any APIs available for GoCD? Extensive. There's very few things that aren't available over the API. So if you go to api.gocd.org, you'll find some pretty extensive documentation. Second here. Sorry. Yeah, so you go ahead with this one if you don't mind. Because it's just a git command, right, Jess?
Yeah.
So somebody asked a question, does GoCD support git submodules? So go ahead.
So yeah, I mean, so once GoCD checks out the repository, you can just set up a task to run the git commands to set up, to update your submodule to whatever version has been set up there. So it's just a matter of adding a small task there.
Yeah. Okay, somebody asked about instead of Kubernetes, can we use Docker Swarm? We have not built or tested any official things for Docker Swarm. There are official Docker images for the server and the agents. So you have to mount volumes and so forth. And so I'm sure that it's technically possible because it's just Docker. But we haven't done anything extra to enable it. Like with Kubernetes, we have the Helm charts. We don't have. I'm not even sure what the Swarm equivalent of that is. We haven't done anything for that.
So just to clarify on the submodule part, I think we just got an update from the GoCD team member. So the Git material will automatically update the submodules, so you don't actually have to set up that task. So it will be taken care automatically.
Cool.
So there's another question around integration with tools to notify developers. There are plugins, community contributed plugins for notifications for Slack as well as email. So you can configure these plugins to send you an email or a Slack notification on a particular webhook whenever certain pipelines fail. So you can configure it at that level.
Okay. So you asked about Docker Windows. I don't know the plans there. We'll try to follow up after with that. A follow-up question on the Git. Yeah, for the Git thing, I think if it's okay, we'll ask someone in the dev team. It's kind of interesting that Pratik's actually a tech lead for a different product. He's a GoCD user. So we don't want to get that question wrong. So we'll follow up with a member of the dev team and get back to you on that question on there. And then...
So there was one around test results, display test results. So if you export XUnit style XML, you can automatically sets up and you export as an artifact. It does set up a results tab on your test run on GoCD to give a better formatted appearance to that. So yeah, if you're exporting XUnit style XML and exporting that artifact, you should see a better test results tab on your build runs.
Yeah. Also, when you store artifacts in GoCD, a lot of times people think of that only as the product of the build, the jar file, the Docker, whatever it is. But it also can be any other output. So like if you're using a tool that's outputs like an HTML report or those kinds of things, you can bring that back up into GoCD. And there's a command in there to create a tab. You can create a tab in the user interface. So you can see the output from any tool that can do text or HTML right inside GoCD. So the follow-up question was like Sonar. Yeah. So you run Sonar, it generates HTML reports. You define that as an artifact, which means it gets uploaded back to the server. And then there's a functionality and configuration that says create a tab out of it. And then you'll see a tab that says Sonar. And it's right there. I should say, because there's a couple of questions about different plugins and so forth, there's a conceptual difference with GoCD. So yes, as Alagu mentioned earlier, there are lots of plugins out there that people wrote for doing Gradle and PowerShell and even Docker and et cetera. A lot of times though, like if a ThoughtWorks team is doing it, we would write a script and have that logic in our source code instead of even using a plugin that's available. So like, somebody asks, well, I'll just use Sonar because we were just talking about that. A lot of CI systems out there, if you want to run Sonar, the workflow is go get the Sonar plugin, put it on your CI server, do all the configurations. That's cool because it does a lot of things automatically. But what's not cool is you now have build, test, deploy logic in your continuous integration server. And so if it goes away, you can't run the tests, or you can't do the deployment, or depending on your level of dedication to those plugins. So like when we build our own stuff, the one I'm going to pick on, and I apologize if the author watches this, is there's a plugin for using Gradle. GoCD team uses Gradle. But they don't use the Gradle plugin. They call Gradle from the command line or wrapped in a script, or et cetera. That way, the server could explode, and we can still do a deployment. So it's just a difference in philosophy, I guess. I'm going to just do, I think, 2 more questions here. Someone asked the advantages over other tools, for example, Jenkins. It's tool by tool. For Jenkins specifically, there is a blog post on the website, because we get asked that a lot. The basic TLDR, the basic short version, is that this was built specifically for continuous delivery. And so, as I mentioned earlier, when Jez and Dave were writing the continuous delivery book, they're trying different things in order to do this, including many of the CI servers that were out at the time. And it's just fundamentally a different thing. And so, created GoCD, the book came out. People started creating plugins that give like a pipeline view, or even the ability to author certain things like Groovy or what have you. But underneath, it's still not exactly the same thing. And so you have to know how to manage those plugins and those scripts and so forth. There's nothing that you can do in GoCD that you can't do in Jenkins. Okay, I want to be clear about that. But it was built for continuous delivery. And so the fan-in, fan-out diamond dependencies that Pratik talked about, and the artifact management that we've talked about quite a bit, et cetera, those are just what the product was built to do. And so it's a lot easier to use, a lot easier to set up, and potentially even safer. And I think I'll let Pratik do one last one, and then we'll probably wrap up. I thought you had highlighted one that you wanted to answer.
No, I was still going through.
Yes, we're live.
Yes. So for installation and integration with VFS and TFS and VSTS, I guess we'll have to ask the team.
Yeah, most of these we'll have to follow up via email, because we want to. There's some of these that are very specific, and they're good questions, but we want to follow up with the GoC team and making everything work. And I think actually with that, I know there's open questions there, but again, we won't drop any of the questions. We'll absolutely follow up with everything. But I want to go back here real quick and just do a quick wrap up. Go to here and go to there. Okay. So just a summary. And again, the video for this will be posted, and we will answer all these questions. But we went over some CD and key practices. There's some other things that we didn't go into that are key, like solid continuous integration practices are prerequisite to continuous delivery. Talked a little bit about modern infrastructure, and as the question with Swarm brought up, Docker and Kubernetes certainly aren't the only solutions. That's just the latest one that we've built, so we wanted to talk about that a little bit. You saw the Docker-based build workflow. Again, and one of the main takeaways there is, to us, it's just a thing. So yes, there were some technology differences. We write the Helm chart and the plugin to store things in Docker Hub, and et cetera. The things that we did to GoCD to make it better supported. But from a workflow perspective, it's just continuous delivery, if you will. Then went through the whole demo and everything. Some additional resources. So everything that you've seen today is available free and open source. You can get it from download GoCD at www.gocd.org. We also do have enterprise support and add-ons available. So if you're a large organization, want to run hundreds of pipelines, there's some performance things. There's some things for analytics to see your agent utilization, others. So there's information about that there. Somebody asked, are we going to, like the commands that Pratik showed during the demo, there's a blog there for getting started that has all that commands and walkthroughs for that. And we do more events and webinars. So we do basic demos, and we're always looking at creating more. So there's information there for that. So with that, I will say thank you for joining us. We appreciate your time. If we didn't get to your question, there's also a 30-day free trial of the support offering itself. So if you email support@thoughtworks.com, we'll make sure that we get you handled. All right, so thank you very much.